Hello everybody, Milosoft here, and today we are going to look at removing the password protection from Security Alert. Security Alert is a game from First Star Software, published in 1989. It is 2 discs, and as you can see here, we only have a boot file. We don't have access to the actual game information, because what it does is it loads it right from the tracks and sectors. So it's going to be a little bit of a challenge, but not a big challenge, I don't imagine. I'm just taking a quick look at the loader. All right, let's give it a go. I'm going to turn on the status just so I can see what track and sector it's on. If you haven't already figured it out, I'm not using a real 64. I'm using an emulator, CCS. Using an emulator than a real machine because you have more access to the memory. So the title page has come up and we have a scrolling message. Type in the character that appears in column 5, row 12. So right away it starts with the copy protection. And the program counter, I pressed Alt-M in CCS to go into the monitor, and you can see it is at A0C6. And A1000 is normally Commodore Basic, but you can see here, if I use the I command to view the memory, it does not say CBM Basic. This is actually game code. Incorrect, restart computer. So this is exactly what we're looking for. The first command is jump A02E. It looks like it's setting up the screen using D016. So it could be the high-res loading picture. So what we're going to do is I'm going to freeze it, and I'm going to purposely put in the wrong passwords. 1, 2, 3. And now it is looped at A128. So let's make some notes here. We don't need 2 notepads. So at 8128, I see it's jumping to 8128. So this is an infinite loop, which effectively forces you to restart the game. So if this is executed, we'll just follow the trail, working our way up. To try and figure out how it gets to this point. Now we have 3 tries. So what I'm going to do is just search, see if it compares the 3 tries. So here, load A013, compare the 4, DCC AOBE. So I'm going to kind of enlighten you into what I'm doing here. The reason I go to 033C is I don't know what the opcodes are off the top of my head. So when I type in compare number string 03, it shows me right here, and I know what to search for. So I'm searching A1000 to see if it compares the 3 tries you get to put in the password. Now, some games, it doesn't have 3, it works on 4, because let's say this is your first try, 1, your second try, 2, your third try, 3. Well, it waits until you hit 4 to lock up. So I'm also going to do C904. And we do have a result at AOC6. So it's loading A013 and checking if it is 4. If it's less than 4, it goes to AOBE. Let's try changing that just to a high number, like 24. Actually, we have to go back here. Oh, goodness. So there's 1, 2, 3, 4. So that is not what we're looking for. I've done a search for load the accumulator with 03, store in A018. Let's see what A018 has. 3. I got it wrong. 2. 1. Now, how did I know that that was it? Well, I'm just going to be upfront with you. I did a little bit of searching before I started the video, and I already knew that it was A018. So there are 2 methods that you can use. You can try searching to see if it reaches 3. You can try seeing if it has reached 4. Or in this case, you can just do a search to see if it loads a value with 3 and then decrements it. So in this case, we know that A018 is the number of password attempts. We're going to hunt for 18A0 because that is how we write A018. We put the low byte first and then the high byte. And I'm just going to write down what our results are. A04E, AOE4, A509. So here it's initializing it with our 3 attempts. Fair enough. AOE3, decrement A018. Branch equal A107. And let's take a look at the last one. Load the number of attempts, compare it to 1, branch equal. So I'm thinking this one here is where it tells you it's your final attempt, because it goes 3, 2, 1, and then the last message. So if you look here, it's loading 62 and 63 with A3 4C. See, A3 4C, and I'm guessing that that is going to be the message that tells you it's resetting the computer. Actually, I have it backwards. If it's equal to the last attempt, it goes to A51A. And that is A36B, which is going to be the final attempt. Okay. So what we need to do is we need to patch A03E, roughly that area. I could change this, and if I do, you would have infinite attempts at the password. But we don't want that. We want to figure out what is causing it to trigger. So it's JSR into A736. I'm going to write that down. And if the branch carry is set, it goes to A12B. So it calls this routine. If BCS, skip bad password. Here's a call to some routine. If carry is set, just skip all of this. So we need to look at A736. What it's doing is it's comparing two values, A019 to A01A. If they're equal, it sets carry. And if they're not equal, it clears carry. So I'm thinking one of these must be the proper password, the proper value it's expecting, and one of them is the value that you input. But we're going to take an easier route. So, you see where it says AODE? The bytes are 20, 36, and A7. 20 is JSR, 36 is the low byte, A7 is the high byte. If we change this to a jump, which would be 4C, and we change this to 2B, A1, it becomes jump A12B. Now, just give me a moment to write this down, and I'll explain what we're doing. Let's give it a try, see what happens. Save the freeze, type any value, and it asks for disk 2. So it looks like we've cracked it. So I'm just going to review it quickly, what we've done. Give you a little bit of insight. So the game starts. It asks you for the password. We go into the monitor. And we know that we have 3 attempts. So we initially hunted for compare 3, compare 4. It was not this one. And then we did a search for A903, which those 2 opcodes mean load the accumulator with 3 for our 3 attempts that we got. We put a wrong password and we found that A018 decrements. It goes down every time we get one wrong. And then we found this routine here, which does a compare. if carry is set, it goes down to A12B. Otherwise, bad password, because it decrements. The 3 becomes a 2, becomes a 1, and then that's it. So we take these 3 bytes, 20, 36, A7, and we change them to 4C, 2B, A1, which is just jumping to where that would go. And we'll speed it up. We'll just type in anything, and there we go. So now we come to the point where we have to figure out how are we going to write this back to the disk when we don't have access to the files. How are we going to do that? Well, I'm going to pause the video, and when I come back, I'm going to show you how. All right, so here's what we're going to do. We're going to use a program written by Mr. Knopp called Discan. And what Discan does is it searches a disk for a series of bytes. We're going to insert security alert disk. We're going to press E for enter. And we're going to put 20, 36, A7, which was JSR A736 in the code that we were just looking at. I'm going to press enter. We're going to press F to find the bytes. Starting at track 1, sector 0. Now this program sometimes crashes. Okay, it's got a read error already. That's not good. (20, 36, A7). Fine, let's start with track 3. Okay, so we have encountered a problem. And that problem is, let's try track 15. So my first thought was there was disk error protection, and then I thought perhaps it uses a custom disk format. So I went a little bit higher in the tracks. I went up to track 15. It seems to be working. There could be error protection on the disk, but we're going to just try from tracks 15 up and see if we can find those bytes. If not, we'll try a little bit lower. Match found. So, track 27, sector 6. It has found the bytes we're looking for. Do we want to modify? Yes. So we press Y. Modify 0680 and save. Or input hex. We're going to press I. Enter new hex separated with space. So we're going to put 4C space 2B 4C 2B A1. Save these changes. Yes. Now, it is possible that those bytes are found elsewhere in the program. I just took a chance that those were the ones I was looking for, but I'm fairly confident that that's the routine that we needed to catch. Track 27, sector 6. Okay, so we are going to reset. We are going to go back to disk 1. We're going to load. And we'll cross our fingers that we have successfully patched it. Type in the character, column 11, row 30. I'm just going to press OK. Flip to side 2. And there you go. We have removed the password protection. Just like that. So You might be wondering about the bytes. $1,000, B1,000, 4C, 2B, A1. So these 3 bytes right here jump A1, 2B. That's a 4C, a 2B, and an A1, which creates jump A1, 2B, which is what I entered into Discan, and it wrote them over top of the old bytes. And A1, 2B doesn't seem to do a whole lot. Yeah. So with regards to those disk errors, I just want to see if perhaps there was disk error protection as well. Loading. Doesn't appear that there's any immediate protection. What this is this is the bootloader. What it does is it closes all the channels, it clears the screen, it loads X with 0, it takes what's at 2F4, prints it to the screen, increments X till it hits 10. So if we look at 2F4, there are 10 characters here, loading, and 3 periods. And then you look at 2CF, it opens 8, sets A to 8, sets X to 8, Y to 0, FFBA. FFBD, it is opening O2FO. A is the number of characters in the file name, and the pointer is at Y and X, so O2FO, boot. So it loads the boot file. And then it does the load via FFD5. It sets A1000 to RAM and jumps to A800. So, well, there you go. You have now successfully patched Security Alert. All right, slap an intro on it, share it with your friends, and we'll see you on the next video.